guys, here we can talk about the insertion sorting. Before we talking in the insertion sorting, firstly we talk about the complexity of the uh, selection sorting, which we can doesn't talk on the previous video. So firstly we can see that the worst case complexity of the selection sorting is O(n) squared because there are two loops. Best case complexity is also improved, which is also O because O n square, which is because of the two loop, and the average case complexity is the O n square because when we calculate the average case complexity, which will be performed into the O(n) square, and the worst case space complexity is O(1), which is because of the auxiliary array. Here's the insertion sorting we can discuss. The insertion sorting is a type of a sorting where we can take the previous and current variables or index when the previous is greater than the uh, previous index element is greater than the current index element, or previous is not equal to 0, so that the previous index element is stored into the next previous element, into the next index of previous element. So when the current is more than the previous, so that the previous in so that the current is stored into the previous of next previous of the element, the current is stored. So this is the instance sorting which we can say. So here we can discuss about the code of the instance sorting, so that from this thing you can easily understand by the code, and after that we can see the insertion sorting complexity also after the code. Firstly, we can switch to the VS Code, and then we can write the code for to easily understanding for you of the insertion sorting algorithm. After that, we can talk about the complexity. So that let's we start. So firstly, we can switch. So here the VS Code is open. So we can write the variable of array, which is not the same example of the book. We can take in the another example or the random example. So that's it, the example. So we can create the method which is the insertion sorting method. Void insertion sorting ind array. In a method we can define the array variable. In method we can defines the n variable also, for which store the array length or array size, and here we create the for loop from I equals to 1 to I is less than n I plus plus increment to the I, and here's the current is equals to I comma int previous is equals to I minus 1, and while condition when the previous is not equal to 1 but not equal to 0, but it is greater than or equal to 0, and array of current array of previous is greater than array of current. So the array of previous plus 1 is equal to array of previous, and the array of previous plus 1 is equal to array of current when the previous is decrement by minus 1. So there, so here's the logic which we can see behind the algorithm. In the algorithm, this is the logic we can see. Firstly, we can declare the n into the method of insertion sorting, where the n is the array dot length, and then we can define the or writing the for loop from 1 to n, where the current is stores the 1 value or I value, uh, and the previous is stores the I minus 1. The current is is the the variable is the index where the previous is the index of the current. The current is the index which is currently shown, but the previous is the is the index which is the uh, previously of the current index. The current previous index is the previous, and the current is the currently index. Current is the currently index, and the current previous index is the previous index. And the currently index is the I, and the previous index of the current is I minus 1. When the previous index is greater than the 0, and the and otherwise agar previous index is greater than the 0, so we can print the previous plus 1, the previous index plus 1 stores the previous index element. Previous is greater than equal to 0, or previous is greater than current, so that we can stores the previous index element into the previous plus 1 index element. And when the current is greater than the previous, and previous uh, plus 1 element is stores the current elements of the array, and then we can decrement the previous by minus 1. And this is the whole of the approach we can discuss into this code of the algorithm. Here's the insertion sorting. We can call the method by returning the insertion sorting name of the method, and then we can print the array by writing the for loop SOUT array of I. Here we can write curly brackets, not the in brackets. So that's it, the code. So we can run this code. Java insertion sorting dot java insertion sorting. So here you can see the array is sorted array of increasing order. You can see the array is sorted array. So that's it, the video. So save this code into the folder or into the VS code. So that's all the video. So thank you all of you for to giving us support, and please subscribe and share and like, and please comment onto the video for to give some suggestions for the improvement. So thank you all of you for to giving us support. Thank you.